Hi, I'm John Schellenberg. I'm a teacher at Renfro Middle School, and I'm also a Decatur maker. And my primary focus is welding and metal stuff. So I'm going to walk you through setting up the MIG welder today. We'll talk about some safety, some tool setup, and where you'll have to go to get the key, and some of the other things that you'll need to know about the machine. We're here on the pad right beside the back entrance to the makerspace, and the metal shed is where the tools are kept. You'll have to watch this video, take an online quiz, and then you'll need to come in for your hands-on safety check. Once you've passed those, you'll get the key, and that will let you unlock the metal shed, and you'll have access to the tools. So you'll just slide the doors open. And this will be the machine that we're talking about today on video. This is the MIG welder that you'll be using. So inside the metal shed here, tucked in along this wall, there's a big bin that has some welding gear, okay? And personal protective equipment is really critical for welding. It's about 3,000 degrees, the arc temperature is, and it's lots and lots of UV light. So if you have sensitive skin, you will get sunburned on any skin that's exposed. So I like to wear a long sleeve denim, but any of the jackets that are here that are in the welding bin, and you'll know because they'll be Miller brand, or they'll be the heavy black jackets, BSX, or the other one here that are the same style. But you want this heavy cloth over your arms all the way down to your hands, and you definitely want to wear some kind of welding glove. So I'm going to put my shirt on. And I'm definitely going to buckle up my cuffs. And that means when I put my welding glove on, my glove goes all the way up over my cuff. Okay? That's going to keep any of the little slag BBs that form when you're welding and splash up off the weld. That's going to keep them from getting into your glove. If you have a short glove on like this, you've got some places still where some of that slag can go in, and it's really, really painful if it sits there and burns. So definitely you want to protect yourself, you know, full length, as much coverage as you can. You'll also find a variety of welding helmets inside the shop. This one happens to be auto darkening, which means when you put it on, you can see through with regular light, but as soon as it detects the flash from the arc, it darkens itself. This allows you to position your welds and do a bunch of stuff without having to flip your helmet or take your helmet off. Inside here, there are some controls that let you control how fast the machine reacts to the arc and how dark it is. So a couple of neat features in there. And we have several welding helmets that are like this. This one's my personal one, so you won't see it in the shed, but there are several that are like that. There are also fixed shade helmets that do not auto darken, and those will be really obvious because as soon as you put them on, it's just nighttime. Another really important safety feature is your shoes, okay? Closed-toed shoes, preferably boots, okay? My athletic sneakers here have this nice mesh, which is great if you're jogging and your feet get sweaty. But like I said, those BBs are about 3,000 degrees, and they'll burn right through this mesh, and they'll melt it to your feet. And that is really, really painful. So what I do is I wear really heavy work boots, and I absolutely tie them up tight, and then I tuck my pants around them, and if I can get it over the laces, I'll try to cover the laces as well. That way any splash or any slag that happens to come off the welder doesn't go down inside my boot and get trapped in my sock or burn my feet at all. So we moved our machine out of the metal shed. The cart is a little bit wobbly, so just be really careful when you pull it out. There's a little bit of a ledge there. Never move the machine with the regulator on the gas bottle. So you'll notice the green cap is on here for safety right now. Okay, we'll set that up here in just a second. All right, so starting off, what we've got here on our cart is the power cord. Okay, this plugs into 220 only. There are two 220 outlets. There's one by the back door, and there's one by the front door. If you drive a Leaf, you know where that one is. And on the front of our machine, which we'll plug in here in a minute, we've got our operating controls. We've got the power button, and we've got the temperature or the arc voltage and the wire speed. We'll talk about how these work together when we start welding. We've also got a plug here that allows the machine to talk to the welding whip. Okay, and so this is what makes the magic happen. We've got a trigger here. This initiates the arc, and this will start your welding. We've got a nozzle, and the nozzle comes off by simply unscrewing it. You always want to make sure that the nozzle tip is clean on the inside, because that will fill up with some welding slag there. We'll talk about that again in a minute. The wire comes through the machine, through the welding whip, and comes out through the end here. And this piece gets burnt up pretty easily, but it is quite easily replaceable as well. Okay, it shouldn't really ever be more than finger tight. So if you need to replace it, you may have to cut the end of the wire off, but you should just be able to screw a new tip on there. Okay, if you notice the little tiny hole here, that's where the gas comes out. So if you don't have the nozzle on, it's not going to protect your weld, and we'll talk about what that looks like and sounds like here in a minute. Okay, so you have to have the nozzle on, and the wire kind of needs to be sticking out a little bit when you get ready to weld. The other important part of welding is the ground. So what happens here is basically you ground your work, and the machine basically creates a short with the wire. So that fuses the metal together. So if you don't have your ground clamp attached to your work, basically it's not going to work. Okay, so we'll talk about that a little bit more when we get some metal out and we actually do some welding. Before we move to our welding spot, I'm going to talk about how to put the regulator on correctly. Again, never transport the welder with the regulator attached to the gas bottle. These things are about up to 2,500 psi, and if the gas bottle tips over and the regulator breaks off, it basically turns into a missile. So always transport the welder with the gas bottle with the green helmet on, or whatever color the cap is. To put the regulator on, you'll just untwist the cap and take it off and set it on the side of the welder right here so that it's always with the welder. Then you'll take your regulator and you'll need to position the regulator with the outlet of the bottle, and then you're going to want to screw this part in. Okay, this is the sealing surface So you really want to make sure that that's clean and not been nicked. This should always stay in a protective bag. Hand tighten it, and then you need to grab an adjustable wrench like this. Do not use pliers. I repeat, do not use pliers or vice grips. It needs to be this wrench or an equivalent. Okay, you just want to snug it up. All right, don't overdo it, just snug it up, and then you can take your wrench off. Okay, these gas bottles seal all the way open, so you have to untwist, and there are directions here for closing and opening. You have to untwist all the way out until it locks in the open position. Otherwise, the needle inside the bottle will leak. Even if this is tight, it will still leak out of the handle. So always make sure this is locked out all the way open. Okay? We've moved the welder from the metal shed and the pad down to the front of the building where the 220 outlet is. All right, and this is the front building here where the leaf charger. So what we're going to do next is talk about our gas settings on the regulator. I move the welder down here with the cap on, and now that we're almost ready to weld, we have put the regulator back in place, and we've tightened it up with our adjustable wrench, and we're going to turn it on and set the gas to the right volume and flow. Remember, you want to turn this gas nozzle all the way on until it's tight in the up position. You've got two gauges here. This gauge talks about the pressure inside the tank. A full tank is probably 2,500 psi, and an empty tank is down to about 100 psi. You don't ever want to run a tank out, or moisture can get in and that damages the inside of the tank. On this this gauge, you want to have your working gas flow at about 20 CFH. That's the red, okay, the inner red. Right now it's at about 25, but as soon as I start welding, it's going to dip down to 20, and that's about where I want to be, okay? That reminder is right here on a sticker, all right? There may be times where 20 is a little too much, and there may be times where 20 is not quite enough, but that's a pretty good place to start for everybody's general welding use. So we're in position to weld now. We got our welder down, we've hooked our regulator up. We move the welding table from the metal shed down here. This gives us a really solid base to work on, and most importantly, it gives us a position to ground our work with. Okay? We've also got our welding curtain set up, and the purpose of the welding curtain is to keep passersby, traffic, and people walking on the sidewalk from experiencing a flash burn from seeing the welding bead. So that's protective for other people that aren't here wearing a welding helmet. Now, on our welding table right now, we've got a couple pieces set up. I've got a couple different pieces of metal. I've got some additional safety gear that we're going to wear, and we've got a couple of different grinding tools. So I'm going to put my safety gear on first, and we'll talk about some of the metal that we've got here. Now, hopefully you bring your own metal, but if you're here to practice, there's a couple things I want you to keep in mind. This racking material is pretty toxic if you weld it. I'm not sure if it's galvanized or if it's zinc plated. It's probably zinc plated, but it's going to burn and create a really, really toxic gas that comes off. Galvanized things like chain link fencing poles and other things that are designed to be out in the weather are even more toxic than this. So if you're going to be welding those, you need to have a proper respirator on and things like that. I don't know that there's any of that stuff here, But if you bring it to the space to weld, please be really, really careful. You only get one set of lungs for your life, so definitely wear a shield or a breathing apparatus. Now on our other metal, these are just pieces that I found in the practice bucket, and they're pretty dirty. They're not going to weld very well. Okay, they'll probably stick together if we wanted to, but we definitely need to clean off the rust. In particular, if we're going to weld along the edge here, we need to clean probably as much of it as we can. Definitely the lip, the edge, and as much of the inside as we can reasonably. Now to do that, we've got a couple of different tools. You've got a manual brush that you can use. You've got grinders that are inside the metal shop. So we just brought those out here with an extension cord. If you use the grinder, you definitely want to use ear protection because they do get loud. And you're always just going to do one little thing and it turns out to be more than you want. So just put them on before you use the device. If you're going to do a lot of grinding, then you want a heavy disc, an actual grinding disc. If you're just going to take some rust off, then there are a couple of different brush options. There's a knotted brush or a twisted brush. There's a straight brush, and there's actually a knotted cup. This is called a cup brush. There's actually a knotted cup brush that has the twisted bristles, but in this shape. What's on the machine right now is called a flap wheel, and this is a really good polishing tool. So if you do your welds and you want to take some of the weld off the surface to make it look a little flatter, then this is probably the device you want to use. For right now, I'm going to try the manual brush, and we're just going to try and take a little bit of rust off the edge here so we can see if we can weld that. We really only want to press in one direction and not go back and forth. And you can see that gets most of the rust off, but there's still some rust inside the material. So we've got the surface rust off, but you can still see a little bit of scaling there. So it's probably time to move to a mechanical disc. In this case, I'm just going to use the flap wheel. We've moved our workpiece to the corner here, and I put the clamp on because I need to hold this device with two hands, one to turn it on and one to steady it. So the clamp here is going to keep my piece from flying off the table. Okay, here we go. We cleaned that with the flap disc. I changed it, and you'll have to watch the tool video to see the changing procedure. But I've put on the knotted brush, and I'm going to clean this edge with the knotted brush so we can compare the finish here and see what we're ready to do when we weld. So always wait until the end of the brush, the cup, disc, whatever it is, has stopped spinning before I put it down. You can imagine this thing jumping off the table if you put it down and that brush makes contact with the table. So we really want to make sure that that is off before we set it down. All right, so you can see the difference here. This side actually ground off some of the surface rust and some of the base material, whereas this side is a little bit rougher, and it's cleaned off the rust down to the base material. If you notice the brush jumping when I tried to do the edge, that's just something that happens, and that's probably just not the right tool to clean such a thin piece of metal. But either one of those sides are now ready to weld versus the finish that we got with our hand brush. We've got our welder set in place. We've got our regulator attached. It's plugged in. We are going to now look at settings that we're going to need to use to weld the material that we've chosen to weld. On this side, so I guess left side of the front, you'll pull this little handle up and flip this door open, and you'll see the filler wire and the drive roller, the tensioner, and then these are the positive and negative poles for the welder. All right, and our little tour of things on this side is our output polarity. So for the most part, we're always going to use MIG, which needs to be DC welding, and the EP stands for electrode positive. The other type of welding that's possible with this machine is flux core welding, where you don't use a welding gas. And to change to flux core welding, if you ever need to, you have to switch the positive and negative leads of the welder. So let's go back down and we'll take a look at where we find those things to fix them. You'll notice a big positive here and the red button, and this little tiny negative here, and this basically goes to our ground strap. So, sorry, let me reach through here real quick. So basically, what we've got here, if we trace our wires, we've got our ground strap that goes in, and that goes to the negative pole of our welder. And then this wire comes down and goes to the welding head of the welder, to the welding lance. So this positive for MIG welding has to be here, okay? And the ground strap has to be on the negative if you're using solid wire. So that's the way we have it set up now. If you change to flux core, you'll have to flip the welding rod to the negative, and you'll have to flip the ground to the positive, and that shows you up here on the sticker where it says gasless flux core, DC electrode negative. Okay, so just make sure if you're using solid wire that you're on electrode positive, the way the machine is set up right now. When you're welding mild steel, you're going to be using this type of filler wire. This is a solid wire, which means you need to use a gas shielding gas versus a different type of wire that has a shielding material inside. We don't have that kind here, so you're probably not going to have to worry about that. But so this material, the important number here is this size. So this is 35 thousandths in diameter. And what matters about that is you're going to use a special side of this drive roller right here. So this part of the machine drives the wire through the welding head and into the weld. And so we need to make sure that the setting on this is correct. And there are basically two grooves in this little wheel. One is for thin wire and one is for thick wire. And 035 is thick wire. So we're going to go upstairs here to this sticker that has our suggested settings and our drive roll orientation. And we just want to make sure that if we're using 035 wire, we have the drive roller set to the right size groove. So I find 035 wire it's solid steel. And so I want to make sure the larger groove, this would be the tip where the wire is coming out, and I want to make sure the larger groove is next to the tip and the outside is stamped 0.8, 0.9. So let's take a look at the drive roll again. And we can see the stamp 0.8, 0.9, and the nozzle is here, and so we know that we are aligned properly now for this size wire. We've got the piece that we cleaned up, and now we're going to set the settings on the welder. So I've measured the thickness of the material, and the thickness really makes a big difference here. So we know the thickness, we know what kind of gas we're using, we know what wire we're using, so now we're going to use all that information on the matrix up here. So we're using MIG welding with C25 gas, and that says that on the sticker. We have this filler wire, and it is 0.35 diameter. Now the piece that we're welding is 1/8 of an inch thick, so we're going to use this setting, E5. Okay? Now on the front of the welder, we have two dials. One for arc volts, that is A through J. That's basically what we call the heat. And we have one for wire speed, that is 1 through 10. Okay? So the suggestion here is E5. So we're going to use that setting, and we'll fire it up here in just a sec. We've got our machine set up. We've got our material clamped down to the table. So let's get our gear on, turn the machine on, and do a little welding. Making sure my gloves cover my cuffs. I make sure that my helmet is turned on the inside, and that my setting is set for my eyesight and preference. Now I'm going to turn the machine on with the red on button. And I've also got our safety shield to sort of block the arc from people on the street who shouldn't be looking at it. So I'm going to turn my machine on. I'm going to turn the bottle on all the way, turn it all the way open until it's tight at the top. I set my regulator before, so we don't have to worry about that at this exact moment. And so now all that's left is to properly ground our work and do some welding. So I'm going to use one of the spots that I cleaned for the welding for the clamp, and I want to make sure that it's grounded really, really nicely. If I clamp it to the table or I clamp it to a rusty side, the ground may not be good enough to allow a good weld. So since our camera person doesn't have, sorry folks, since our camera person doesn't have a welding shield on, I'm going to block the light from the weld with my glove. But you should be able to see what's happening, and then I'll show you the weld as soon as I stop. All right, now that's a nice clean weld. It was on nice clean material, but you can see some of the burn, some of the stuff that's going to happen. You've got a little BB right here, and all of the sparks and stuff that are going to fly off the weld. That's the reason we want to wear the closed-toed shoes and the long gloves and the shirt, and sort of protect our surroundings from all of that slag metal that blows off the weld. We finished our weld, and now it's time to shut the machine down, take the regulator off the tank, and move the device back into the storage facility. So the first thing we're going to do, we turned our machine off when we got done welding, but now we're going to turn the gas off. So we're going to turn all the way down, okay? And we need to bleed off the line that goes to the gas, to the welder, okay? So I'm going to turn the welder back on for just a second, and I'm going to squeeze the trigger until I see this gas go back down to 0. It takes just a second. Now I can turn the machine off, okay? And I'll need to trim this wire off so that it doesn't get stuck on stuff or poke people. But now my regulator has been bled of pressure, and I can disconnect the regulator, put the cap back on the bottle, and then the machine is safe to transport back to storage. We finished up our weld, we packed up our stuff, we brought the shield back up, we brought the welder back up, and we've put everything back into the shop. So now it's time to close the doors. Just slide them shut. Make sure that the lock gets locked, and that you take the key and you put the key back inside the key box inside. If you had any trouble with the welder, or you need to report an incident, I don't know, damage to the welder or trouble or whatever, email info@Decatur Makers, and somebody will get back to you pretty quickly.